Wonderful. Okay. Everybody, thank you for taking the time to join us today for our spotlight on Make Productivity's latest enhancement, 2D features and drilling automation. My name is Rob Kobielski, and I'm joined by my colleague, Alan Jenkerson, who will be moderating today's call. So please feel free, send your questions anytime, and Alan may answer on the spot or queue them up for discussion at the end of the live demonstration. A little about me. I first joined manufacturing in the late 90s as a general machinist, and after some years specializing in CNC and CAD/CAM, I joined Delcam in 2013, Autodesk in 2015, and now for SolidCAD, the largest platinum partner of Autodesk nationwide. I'm fortunate to be surrounded by a team of highly skilled professionals that are dedicated to advanced manufacturing as well. And one of these fine folks happens to be a key developer of this product, and he's with me here today. So please, hello, Alan Jenkerson.
Hello, everyone. Like Rob said, my name is Al Jenkerson. I've been an application engineer for SolidCAD for almost 3 years now. On top of that, I have close to 2 decades of experience improving CNC machining efficiency using automation. This includes everything from simple CNC G-code automation to custom programming automation software like SolidCAD's Make Productivity, which we will be seeing here shortly. Also, this presentation is being recorded. If anybody wants a copy of the recording, we'll be happy to send it your way. With that, I will hand it back to Rob so he can begin his demonstration of the newest and most anticipated feature, Make Productivity. Rob?
Thank you, Al. Kind of gave me chills there at the end. So today's live presentation is going to go straight to the goodies. So this way we can keep to our half-an-hour target. So what you're going to see first is a quick 5-minute experience of daily programming with drilling automation. We're then going to verify the completion of the drilling and go about adding any new holes to demonstrate the evolution of growing your own programming standards. Lastly, we're going to extend the automation into the slots and the pockets on our particular job to demonstrate how quickly and easily you can knock off jobs with Make Productivity for PowerMill. I hope you find this to be a good use of your time, and I certainly look forward to your feedback. Okay, so I did have a quick scan of the audience and those registered to this webinar, and I know a great deal of you are already familiar with PowerMill, but for those that are not, regarding drilling, one of the first things you have to do first is effectively hole recognition. You got to scan the model and identify your holes first. Okay? And we built this part of the process into our new tool here, 2D automation. Now this tool, 2D automation window, it was designed to be used on a second monitor. So I am going to slide this over to my other screen, but certainly it is going to be docked. So if you're working on a single screen workstation, that is not a problem at all. Okay? So I'm just going to maximize my workspace. So in the project that I have preloaded, the only thing I have in here is the CAD model and my cutting tools. I do not have any hole recognition done at this moment, and I don't have any toolpaths yet. So we're going to launch straight into that. Okay. First bit is either selecting holes of a particular color, or just go ahead and grab every single surface on your model and let PowerMill do the work for you. And that's what I've opted to do in this case. So right now we're doing a quick little scan, and PowerMill has returned the following recognized holes, and it's giving me an opportunity to reverse any if I need to, or, for example, if I had 2 holes adjacent or across from each other in an empty space, I could connect those hole segments together. It just gives you an opportunity to have a play with these holes first before you continue along. But I was quite happy with everything I had so far. Okay. And I'm just going to explain, these little bit of messages that I'm going to get here and there. Okay. The first part of the process was recognizing holes, but it hasn't tagged them yet. And the second step of the process is to now look at your particular hole standards, which this is a database that you're just going to, grow in some time. And it's going to compare those engineering standards and those programming standards to the holes you've now recognized on your model. Okay? So again, for those familiar with PowerMill, they may be looking at the whole feature set portion of the Explorer bar to see what's going on. Okay, message simply says, hey, I've recognized some holes like your 1/2-inch tap hole or your fixture holes, but maybe I haven't recognized some, or maybe there was little fragments of holes in which maybe it just gave me some drill tips that I just didn't happen to need in this particular project. This particular set, though, we've purposefully omitted from this portion of the presentation to show you how you can quite easily grab a hole and add it to your standards. Right? So with our holes now recognized, the last button I have to hit is simply drilling automation. And it's intended to be a pain-free process. So at this moment now, I get to sit back and I'm just going to watch the toolpaths populate under the toolpaths folder. And they certainly are calculating as they go along. Right? So you can expect to see those 3 recognized groups of holes all completely programmed. And once that portion is complete, what I'm going to do is simply use one of PowerMill's simulation features to kind of like pretend I just want to verify quickly what holes have been completed and what holes are left for further programming needs.
Now, Rob, you deleted those 2 untagged feature sets before you calculated the toolpaths. What would have happened if you left them there?
On account of they were untagged and unrecognized, it would have been just fine. It would have just completely ignored it, overlooked at it. The only holes that are going to get programmed, like the ones that you saw populate in this list, are ones that are recognized from your built-up database of hole standards. Okay, so naturally, we already knew we were missing those big holes, but obviously with this simulation feature, not only was I kind of double checking, hey, am I happy with my order of operations on all these toolpaths, but like I can visually see or even use some of PowerMill's sim compare features to identify bits that I've missed. But we happen to know with certainty, yes, indeed, we've got to add some to our chart programming. Okay, so no big deal. Let's see what that would look like. I'm just going to put that session aside and open up this second session for a moment, just to show you that this part of the process is now where whomever the leader is, or the person that, if there is a single person in charge of growing your automation standards or your engineering standards, they can sort of take control of building up that database. And it's just a matter of having that particular hole from your CAD room or something like this, and using this same tool in Make Productivity, but this time defining the new hole. So when I define the new hole, you're just simply going to give it a name, identify the feature set. If you have some variation in the sizes of these particular holes, you can add a tolerance to allow some flexibility. And then simply once you do so, you're going to add your order of operations. So I'm going to start this rather large hole with a spade. The spade's going to drill through it. Then I've opted for this helical roughing operation. If I happen to have a larger diameter tool on hand, I wouldn't necessarily have to do 2 of those helical operations. I can simply do 1 with a larger diameter tool. Okay? And then, of course, a finishing operation. So your visual confirmation of the order of operations is down here in this list. And once I'm happy with everything, I'm simply going to hit save. I'm going to close this guy out, drop that session off, and bring my program back. Now you'll notice I had 2 different sessions running. Okay, and this automation was designed to be shared amongst programmers. So it's nice to know that you can actually have a large database of programming standards be shared amongst a number of people, and they can be accessed by multiple stations without issue. So I just wanted to point that a little bit out. Okay. I'm going to bring this window back up, and I'm simply going to repeat the same process that I did before. The feature set we already know is tagged, is created, but it wasn't tagged. And now that I've added it to our standards, it should be recognized this time without issue. So here was that remaining untagged hole feature set. And I guess I didn't mention this before, but this is if you wanted to filter out the kind of machining you're trying to program right now. So, you can at that moment decide, choose your own adventure. I want to do 5-axis drilling or 3+2, for example. So this hole has now been recognized as a 3.5 GB hole, and I'm going to run my drilling operation. So now we should see it simply populate in this list right underneath where it left off last time. And what the heck, we might as well simulate those toolpaths once they come through, just to ensure we're happy with the order operations.
I never get over it, but I love how easy that workflow is.
It's supposed to be painless, right? I mean, it's easy for us to say like the drilling should be pain-free. But the reality of it is a little bit different because, I mean, let's face it, different design standards might be out there. Different CAD systems and stuff like this can lead to, some fragmented data sometimes, and you have to build a robust solution that's going to be able to handle, all of those different outcomes, I guess. So I like to think we nailed it here. So beautiful, you're right. The job's actually really easy, and the presentation is really easy today. We're more than halfway through because we've already done all the drilling on this job. So as I promised, what we want to venture into now is taking this same train of thought, or taking this same optimization that we use for drilling, and now apply it to the 2D pockets. And unless I'm mistaken, I haven't really seen drilling methods per se for pocket work before. So I think we're venturing into some new territory, Al, unless you've seen something I haven't.
No, definitely not. That's why I love this feature too.
Okay, so I'm just going to go back to where I was. I'm going to pull this menu back for a moment just to show you that the top stretch was for drilling and the bottom stretch is simply for milling. So what I'm going to do now is I'm going to create my feature groups, which is, again, is just feature recognition for Power Mill, looking for 2D pockets. We'll tag them and run the automation all the same. At this moment, I could simply select pockets of a particular color if I had wanted, but again, I'm just going to grab them all. And let's see what Power Mill does for us. Same idea as before. It brings up an untagged feature group. We just simply take the next step in the process to say, hey, take a look at these features we made and do something with it. Okay? So perhaps it's a matter of a lack of creativity, but I simply call these things green slots, orange pockets, and pink pockets. But I think we get the idea. You can call them whatever they are, whatever particular feature they are, whether they're for a standard component or even something that you do kind of custom in-house. Okay. So now let's run the milling automation on these guys. Now these bits, they're perhaps going to take a little bit longer to calculate because now we're actually making milling tool paths to go along with these pocket features, right? So depending on resolution of your screen and how well zoomed in, I don't know if you can kind of see what's happening as these tool paths calculate, but the first operation that had calculated was a roughing of those green slots. And then, of course, it's just going to do the same thing, pocket and feature at a time. And what I suspect most people will appreciate from this is that each feature is being approached uniquely or appropriately, I guess I can say. The slot features, they were approached from above because quite clearly they are a closed region. And the tool can only enter the material from the top. Whereas the open pockets on the side may be entered from outside the block. So long as you've got enough travel, in your machine, no problem at all. Right? It'll simply program and approach the material from the outside of the job. So I believe we're on our last operation. And hey, with a little bit of luck on our side, when we simulate this, it'll actually look sensible. And I hope so, because I mean, hey, we're being recorded right now, right? Okay. The style of milling is, this is completely personal preference. When I had created the programming standards for these slots, we opted for sort of like a full flute depth of cut, as opposed to maybe more traditional approaches of a small depth of cut and large step over. But again, this is personal preference. Like, you have full control and full autonomy of how you build these programming standards. So, we implore you, if this is of particular interest or value or sparked some ideas, we'd love for you to send us some feedback, reach out to us. If you want to see how it would fit your operation, we've got trial options available, and most people, I think, are pretty familiar with us as a company, SolidCAD, or even just us personally, because as I said, a lot of us used to work for Autodesk Direct before too. So we might already have a personal connection. So we really do welcome your interest, your curiosity, and heck, we can schedule on site, come see things and have a discussion. So oddly enough, my job's done already. So Mr. Al, I'm going to cue you up. I'm going to put you on the spot, because you know how I go. Sometimes once I start talking, I lose my train of thought, but I feel I showed what we had discussed.
Absolutely. There's no real questions at the moment, so I think you've done a great job explaining it. If anybody does have questions, though, please reach out. Yeah, no, everything showed nicely. And you know what? If I was programming this plate manually, there's no way I could have done it in 10 minutes, if that.
That's 10 minutes with my run-on sentences.
Yeah.
So we can imagine how quick it can actually be if I would expedite my mouse clicks, right?
Yep.
Well, that is good. And you know what? This is exactly what we wanted today. Today, we did not want some big, long, drawn-out presentation. We just really wanted to highlight, like, PowerMill has an incredible wealth of power and options. And if you can harness them, in a product like Make Productivity, you see how you can really optimize, take things and just kind of like roll with them. So yeah, please, if you find this of some bit of value, please reach out to us. There's our email address right here on the screen, our phone number, call anytime. And if you'd like a copy of this, we can certainly send out the recording later on.
Absolutely.
That's great. Well, thank you very much everybody. Please enjoy the couple extra minutes to your day, and have yourselves a great rest of the week.
Take care, everyone.
Bye-bye.